Hi, everyone. Hello, everyone. It's great to be with you today. Let me just get rid of this. Today I thought I would just go over the multi-chain for auditors. As an auditor, what should you be thinking about if you are considering, taking your skills and time in the multi-chain? And hopefully that will, save you some time, like what I share today, hopefully will help you formulate your own thesis about that. So the question we're asking is, as an auditor, where should I invest my time in terms of learning, looking for audits, doing bounties, and so on. And so there is a lot there are many factors that you could consider to inform your decisions: toolings, domains, ecosystems, a lot of things that you can think about. But in my opinion, that's the hard way of going about it. The smart way is to simply look at where the developers are going, not only where they are now, but where they are going next. So the difference here between the low and high IQ is that the former is focusing on the status quo, while the latter is keeping in touch with the trend and tries to get a head start by predicting where the developers might go next in large numbers. Of course, developers don't jump from one place to another every day, but it happens gradually and then all at once. Some paradigms and domains are like sticky and like they will continue to grow. So there will always be some demand there. But I think it's also good to try and predict where the trend is going as well. So we can reformulate our question instead of where should I invest my time and skill into where are developers going. So it's not so much about what you personally feel about certain toolings or domains or ecosystems. It's about where you think developers are going to go. So where do developers go? So today I have a theory and I'm going to share it with you. So the premise is this. The premise is that the time and the skill of an auditor is her capital. And the way she's going to spend that capital is to maximize two things: efficiency and effectiveness. So efficiency is how fast can you get your software out of the door. Remember, we're talking about the developer here. And effectiveness is about the reach and durability of your software. Nobody builds the software because they want two users to use it. Like everybody wants their software to be as widely used as possible. So these are the two factors that the developers are optimizing for, like whether consciously or not. We can formulate our inquiry into a problem statement. So the problem statement is, what is the domain, context, and scale independent law that has thus far shaped software evolution in the past 60, 70 years? So what evolutionary adaptations have emerged in order to maximize efficiency and effectiveness? As developers go about and in the back of their mind, they're always optimizing with these two. What kind of what adaptations have emerged? And the solution that I think to that problem statement is the law of outsourcing of concerns. So outsourcing of concerns via abstractions is similar to how, like in nature, the vast majority of genes have very few interactions in order to make it easy for the process of random mutation, non-random selection to be as efficient and effective as possible. So that's a manifestation, like loosely connected genes. And here the manifestation is outsourcing of concerns. This is how software development, this is the adaptation that has emerged in order to maximize those two things that we talked about. So each layer is in the abstraction stack. Each layer is completely separated from the other. Very clean separations. The people who are working in one level of the stack, they know nothing about what the others are doing or how they're doing it. Nobody cares about what's happening underneath or what's happening above. Everything is cleanly separated. So this is, like, I think is obvious. Now that we know what developers optimize for, and we know the law that shapes software development in response to these optimizations, We just need to start looking for blockchains. We need to look at the blockchain software development through this lens, basically. So the most pressing concern, obviously, in the blockchains is trust, basically. Blockchains are basically a trust API. So we can assume that developers in the long term, they will outsource their concern to the most durably reliable and secure API provider or a chain that gives them that gives them the most the best way to outsource this primary concern. That's their raison d'etre, basically. Now, implementation. How are we going to implement this, what we have laid out so far? Well, sharded blockchains have the most viable path towards durable security. This is my personal opinion. This is you could have a secure blockchain right now, but if it's not sharded, or if it does not have a path towards sharding, it will not scale, and therefore it will die in a different way. It might continue to be secure, but it's not usable, basically. So the only way for you to scale and still keep that security and not compromise on that API, you need sharding. So that's our implementation. How do we know if we are wrong? How do we know if what we have laid out so far, this thesis, this investment thesis, is wrong? Well, if monolithic or app-specific chains proliferate, then we know that we are wrong, fully or partially. So that this is basically a way to falsify your thesis, basically. This is just a side note, which is not really relevant to our question today, but just to illustrate the point. The law of outsourcing concerns continues to manifest itself. We are all familiar with infrastructure as a service, platform as a service. The cloud generally really is a phenomena of abstraction. We have seen low and no visual programming explode since the year 2015. And most recently now we have AI-assisted programming, which might augment or completely replace the low, no, and visual programming paradigm. So to summarize, concerns want to be outsourced. Trust is the major concern to be outsourced. Sharded blockchains are the most likely to continue to be secure. That's why I emphasize the word durable. And therefore, that's where the developers will most likely go, because that's where they maximize those two things, effectiveness and efficiency. Working hard is often glorified. Oh, I'm digging in, I'm hardworking, I'm reading everything thrown at me. But you don't need that. You don't really need that. You could work smart. And working smart is identifying the principle of what makes an ecosystem viable, and then dismissing everything except those that meet that principle. So you have saved yourself a massive amount of time. If a project is insecure by design, you don't have to dig into everything else about it. It's go-to-market strategy, tokenomics, governance, some technical mumbo jumbo about formal verification or fancy consensus algo. You don't need to concern yourself with any of that, because if it's insecure, it's not viable. Again, you don't have to follow this exact thesis, but you could come up with your own and just follow the same methodology, basically. The idea is to save yourself a lot of time. So you could, the thing that you're looking for could be different from mine. I argued for shared and durable security. It could be something else for you. It could be a mix of two, but the approach should be the same. So let's have a quick tech recap of the blockchain. Notice that we're not paying attention today to tokenomics or marketing or governance or anything. This is purely from a technical point of view. Where will developers go and build? And therefore, where are we as auditors find jobs and demand, basically? So there are three major milestones. In each of these milestones spurred incredible innovations, but it also spurred a lot of side noise, each of these three milestones. Bitcoin introduced a paradigm shift in human coordination, obviously. It is it showed that it's possible to have secure, trustless, disintermediated coordination. It was app specific. The only thing you can do is send and receive coins. Well, not an actual coin, but something called UTXO, but I will not go into that. And to ensure determinism across all different architectures in which a node run, each transaction is specified in unambiguous platform and implementation independent instructions, which we call opcodes as part of a virtual machine. So you don't have floating point arithmetic and stuff like that. And all blockchains that came after Bitcoin, they all ensure this fact as well. A higher level language that translates into these opcodes in Bitcoin could be in principle be built like a compiler basically. If not for the fact that these instructions in the Bitcoin VM are not generic enough. It's a mishmash of hard-coded intentions that are not useful for like really fabricating generic constructs. Think of it like this. You have a stake, a hammer, a duct tape, etc. You can use them to fashion a couple of things, say a DeFi vault or an AMM, but as you can imagine, this would be very messy. And some people actually tried to build something on top of Bitcoin, to build like a generic scripting language on top of its script, but they all reached a dead end. You can't really have higher level intents on Bitcoin's virtual machine, full stop. If you hear Bitcoiners talk about, they keep talking about UTXOs, witnesses, covenants, stuff like this. You may get the impression that this stuff is so advanced that only wizards understand it. But the reality is really the opposite of that. Bitcoin script is probably like one of the most amateurish pieces of SDKs ever built. I'm talking here from a software point of view. It's undergrad course project level of quality. But very important, this does not take anything from the genius of Nakamoto and his legacy. Or I should say their legacy. It's not their fault Bitcoin's runtime never improved. It's the fault of the people who captured the code base and the culture that surrounds it. Anywho, lots of clones over the next 8 years or so, and with the exception of Zcash, maybe none of these really are interesting. There is some interesting, Zcash is kind of like evolving nicely, and there is some stuff to look at there in terms of like ZK stuff, but the rest are basically clone. So it's important to emphasize that they inherited, because they're just clones, they inherited this limited VM. From an auditor perspective, there has never really been much to do there. No apps being built, as we said. The consensus node, it sort of got audited in prod, trial by fire in early years, and then it ossified. So in short, as an auditor, you can safely ignore all the coin chains, most of which are basically clones of Bitcoin. Except with the exception of Zcash, which may have some ZK stuff that are maybe attractive for auditors. The next milestone is the EVM. So Vitalik recognized that this Swiss Army knife that he called Swiss Army knife of Bitcoin script is not really sufficient. We can't afford to fashion and refashion this or that thing out of this clunky stuff. We need a proper, fully generic and stateful VM. And so the EVM was born. The EVM is a favorite target of armchair critics because of some design choices that were made early on, like the 256 instruction bit length. These criticisms are valid, but still, I think that Vitalik, Gavin, and the rest of the early gang got it mostly right. Is underappreciated, in my opinion. So this is the main developer of Go Ethereum. He was explaining some optimizations around this choice of 256-bit. As you can see, this is from 2016, so shortly after launch. He was converting big N to N64 basically to achieve some optimization without violating the specs, because according to the specs, you should allow up to 2 to the power 256 number of operations, but because we know that the gas will whatever operation will run out of gas, there is no reason to do arithmetic in those large numbers, basically. So anyway, in terms of auditing, dApps started trickling almost immediately after launch. Prediction markets, ANS, the DAO. And then 2017 came and the ERC explosion, ICOs, but still not a massive demand for auditing because it was just basically copy of the same ERC20 standard. It wasn't really until DeFi summer that auditing exploded. But going back to 2017 first, the success of Ethereum as a fundraising platform mainly for the ICOs, like it spurred an explosion of chains. Starting with the grandfather of Ethereum killers, probably Neo, like the Chinese Ethereum. Of course, it was an EVM clone because, why not? And then you had a bunch of chains that had like new consensus algorithm. So around the same time, 2017-18, the typical script, or the typical narrative of white papers, blogs, podcasts goes something like this. Ethereum is good, but did you see how CryptoKitties clog the network? There has got to be a better way. Here's a flyer to my ICO where I prove using PowerPoint engineering that my chain is better. Buy my token. Now, to researchers and developers, this was hilarious because the consensus algorithm is not the bottleneck of scalability. It's the load, the amount of work that a node needs to do. And that amount of work needs to be kept low in order for people to afford to run a node. And the more people run a node, the more decentralized, the more secure. In Avalanche specifically, you could have something called subnets, which are side chains. And that project, they spent a significant amount of time spreading misinformation about their security and comparison with rollups. But of course, the main chain provides zero security to any of them. The only relationship between the main net, the main chain and the subnets is administrative. Self-selecting subset of validators can validate these subnets, and there is absolutely no notion of validity, prod proof, slashing, or anything. So, it was mostly narrative. Things got weird. I include this example. There are others, but I include this one because it used a concept in computer science to sell a scam. Basically, it was a goofy thing that fooled a lot of people by claiming that channel-based computational model is instantly, massively parallel and scalable. So if you use Golang channels, it's similar to that. Think of the channels like communicating over channels as the computational model. So of course, anyone could immediately see that this bandwidth basically becomes the bottleneck. The bandwidth becomes bottleneck because you're basically computing by exchanging messages as opposed to modifying storage and memory, the usual imperative paradigm. So not only is this an unusual paradigm and an old idea that has never been used, it also is not scalable because the bottleneck becomes bandwidth. Anyway, just wanted to mention this because it was funny when I saw it. And then also around the same time, and maybe a bit later, except for Thesis, which came earlier, you have what I call the formal verification snake oil. The marketing narrative capitalizes on the constant reports of hacks, especially in Ethereum, starting with the DAO. I talked about formal verification before, but briefly, it is not a panacea. Your spec could itself be buggy, and you may miss out on some invariants. Formal verification-friendly languages, mostly functional programming languages, are extremely developer-unfriendly. As an example, we have Michelson in Tezos or Haskell in Cardano. And if you think about it, we would be safer driving around in tanks, right? No one will die from accidents, but we don't do that for obvious reasons. Same thing here. So dApp developers, they just want to get shit done. And history has shown that the imperative paradigm is the most suitable for the average human brain. Sure, if you are writing a script embedded in like a heart pacer or in an airplane autopilot or something sensitive like that, sure, maybe it's worth it to use functional programming. But in the general case, you don't really want that. Another point around this issue of formal verification is that you can formally verify other source code as well. The ETH2 deposit contract, for example, was formally verified to death, and it's written in Solidity. There is some work that to be done because you need to translate Solidity, you need to write like spec for it, but you can do it in those specific cases where the stakes are extremely, unbelievably high. So it's not like you can't harness formal verification unless you use unfriendly languages. This is the Tezos friends, they get triggered when I mention this on Twitter. It's one of the few times that I see them get triggered, but in my opinion, my honest opinion to that community is that Tezos is a hobbyist project for a functional programming fan. It's not useful for anything else. And this is supported by the fact it has been in production for 7-8 years now. There is basically virtually no developer activity whatsoever. Same thing for Cardano. You see the marketing, but then you see reality. Look at Haskell. Nobody is using it outside the blockchain, let alone in the blockchain with the quirks that come with it. In addition to it being unfriendly to the average developer, it has a horrible dependency management problem. I tried this for fun. As you can see, it's not a promising sign. One thing I should mention is in Cardano and all the blockchains that use generic languages, you have to chop off limbs from that language. You can't use it as is, whether it's Haskell or Rust or whatever. And the reason is that you need to ensure determinism in the blockchain context. So on top of the regular mess with versioning in Haskell and the unfriendliness of the functional paradigm, you also need to deal with this problem. You need to deal with the fact that the tooling will always be clunky because you have this Humpty Dumpty wrapper compiler around them. So it's basically a mess. Of course, we did not have to talk about any of that stuff because none of these blockchains are sharded. So we could have skipped them, but I just talked about that just for your info. I should mention Thesis recently created on-chain fraud prover to spur developments of optimistic rollups, but you still have to deal with their developer unfriendly tooling. So I don't think it's going to go anywhere. Next, we have the UTXO cult. Cardano is again there representing. We have something called Nervos, which is, I think it's mostly dead now. And the idea is to take the UTXO model and generalize it. Instead of an unspent token, you have an unspent script. Yeah, so you can't really have multiple transactions in a block mutating the same state using this model. Because the result of one transaction, the unspent transcript, it has to be committed first before another transaction can mutate that same state. It's fundamental to that model. So unsurprisingly, like there is virtually no apps, successful apps with this model. I have asked many times for people who are fans of this stuff, show me an example or show me how you would have a stateful DAB like Uniswap, which many transactions hit in a single block, and it's still and you still get the same result, equivalent result in the UTXO model. You cannot have that. So anyway, next we have Cosmos. Cosmonauts, they value sovereignty over security. That is core to their philosophy. Chains are independent and they can tweak the standard SDK to their liking. That means, according to their thesis, we need not look further. Sorry, according to our thesis, we don't need to look any further about what run times are there or how the ecosystem is, because immediately this violated our principle about durable security. Security here takes a backseat. But if you're curious, Some chains in Cosmos are EVM clones. There's a lot of them. And some, they are for token transfer only. Basically, if you take the SDK out of the box, what you get is token transfer only. It's just Tendermint with token transfer, nothing else. Some chains, you can take the standard SDK, Tendermint, plus token transfer, and you can bolt things into it using another SDK called Cosmos SDK. An example of that would be Osmosis or the upcoming DYDX. Last time I checked, there is not much happening with Cosmos because your dApp is actually baked into consensus. You are baking it into the protocol as opposed to writing smart contracts that you feed into a virtual machine. So like having a virtual machine and smart contracts is an afterthought in the Cosmos ecosystem. I should mention one of the most successful marketing strategies in the history of blockchain is Cosmos drowning the word sidechain in an ocean of sovereignty narrative. So you will never see the word sidechain in any of the marketing stuff. That coupled with some of the best galactic graphics I've ever seen makes it like a very, very interesting ecosystem. I should say though, like to their credit, to the credit of the people who work in the Cosmos ecosystem, they don't engage in misinformation campaign about what their philosophy is. They do say that, you know, sovereignty is more important to us. You may have seen recently though that some of them, like they talk about shared security through mesh security or interchain security. And both of these things, they are simply big blocks in disguise. So they are not shared security whatsoever. They are just big blocks, which goes against security. If you don't know what that means, search it. You will find a lot of stuff on it. Moving on, so we have Solana and Divinity, and it's best to think of these two as SaaS solutions. There isn't much differentiation between a developer deploying to these two or deploying to AWS. It's not that the differentiation is not that big. In Divinity, the last time I checked, to run a node, you need to fill out a type form, and there is a backlog. The number of operators in Divinity, there is like 69 of them. So you have to wait in line. You have to apply to fill out a form and apply. And if you do become a node runner, you get compensated through a fintech company in San Francisco somewhere, the first of each month. This is true story. Solana has no sharding philosophy, and its founders believe that you can have scalability with good engineering and management around bandwidth. It's very costly to run a node. It will continue to be because it's core to their design. They need this high throughput, and they need having high throughput and cheap fees. This is core to their philosophy. So we can assume that it will continue to cost a lot. So we can stop here. This violates our thesis of durable security chain. We don't need to dig further. We don't need to listen to what Anatoly is talking about, like jargon, mumbo jumbo here and there. We don't have to engage in that. But if you're curious, here's from my perspective, here's the little dirty secret of Solana. Execution is optimistic, which is fine as long as transactions on a block are not touching the same state. But if too many transactions touch the same state, then ordering become important. And I have asked this many times on Twitter, like I've engaged in so many debates around it. I'm still not convinced. I have not received a convincing answer. So as long as Solana has these islands of dApps, NFTs, AMMs, like relatively isolated, it can continue to afford having this high throughput. But if you have 70% of the transaction in a single block all touching the same state, then I think their optimistic execution will begin dragging on the on how fast a block becomes committed. Okay. Last two is Polkadot and Near. They are both sharded, although to varying degrees of readiness. They have not, they are still far from completing sharding. But at least they were built from scratch with this intention. So in 2017-18, if you read the design documents of Polkadot, you will find it very similar to Ethereum at the time, to what Ethereum was thinking at the time. It's almost the same idea. And very shortly, the idea was that fraud proofs will be used to revert invalid states of shards and then slash the offending subset of validators of that shard. And also, more importantly, you will, when you as a validator take over the validation of a shard, you don't have to re-execute the whole thing from scratch. Basically, you will take the last state and you will build on it with the confidence that no slashing happened, therefore it must be safe. So this was the thinking back at that time, and it was the same thinking in Polkadot and Ethereum. Ethereum changed its mind in later years and dropped the whole idea in favor of pushing sharding for rollups in the near future for a couple of reasons. Inter-sharding communication turned out to be extremely complex. No one could even begin to put forward a simple design for that. It seems to be completely intractable. Second, fraud-proof-based sharding opens up a can of worms when it comes to attack vectors, especially when the network is partitioned. So you can imagine a proof-of-stake network, and there was a partition, and then someone committed proof, but this partition continued to chug along, but that transition it had to slash and revert, and then how do you reconcile the two? It's a huge mess. Polkadot will also come to the same conclusion, and it will learn this the hard way. Basically, they did not come to the same conclusion. They continue to insist that this is how they will do it, but they did not manage to implement this fraud-proofing mechanism to this day, which they called fishermen back in the time. But this is not to say that Polkadot was not busy doing other things. They built Substrate SDK, which is probably the most sophisticated blockchain SDK, outside of the EVM ecosystem. In terms of VMs, the EVM is present in both Polkadot and Near. It was relatively easy to have the EVM parachains in Polkadot, thanks to the modularity of Substrate, which, well, it's basically decouples smart contract runtime from the plumbing of consensus, so you can really have anything in any virtual machine in there, basically. The plumbing that I'm talking about is the connective tissue, basically, between a parachain and the relay chain. So a parachain take the Substrate SDK and instantiate it with whatever EVM they want, and then you have all this plumbing around it that handles the connection with the relay chain. You can write smart contracts in a DSL called Ink in Polkadot. It's a restricted and macroed version of a DSL, a rustic DSL. So it's basically Rust, but it has yet to gain any traction. That rustic DSL Ink, it compiles to WASM naturally, because Rust compiles to WASM. Near, I think we said everything about Near. Well, its idea of sharding is actually solid. You have these chunks thrown at a single block by different subset of validators, and it's the idea is actually, if you look into it, it's not that dissimilar from the data sharding approach that Ethereum is aiming towards. So it's the necessary plumbing for sharding is, I think, healthy in Near, and they might get there. In Near, you can write smart contracts in JavaScript and Rust because they both can target WASM, and WASM is the main runtime in Near. But there is also an EVM chain that is chugging along the main chain, basically, with one of the best bridges connecting to Ethereum, an optimistic bridge that was tested successfully in the wild. There was successful slashing. I think so. Sharding is not complete in both, but they have a viable path towards it because they laid the groundwork for that. The ZKPs, zero knowledge proofs, they may allow them to leapfrog into full sharding, and it will allow them to catch up with rollups basically, but we'll see how that goes. I just learned about this yesterday. There is actually a project that is developing ZK circuits for WASM, so this might help them to make it there. Okay. Notice that we are still under the EVM banner because all of these ecosystem we talked about so far, with the exception of Tezos maybe, they all came about in order to ride the wave that is Ethereum. They wanted to replicate its success, address its faults, or at least that's what they claim to, etc. Okay. So let me, auditing. So the EVM and clones, you already are familiar with that. The new runtimes with potential, this is Rust. You can safely ignore all the developer unfriendly runtimes, such as those tailored to form verification. This is basically a summary of what I have talked about so far. So the two things that stand out so far is EVM and Rust. With our final milestone in blockchain tech history is rollups. So rollups did not happen overnight. It took one step forward, two step backwards kind of progress, especially for optimistic rollups. But briefly, we know that interactive fraud proofs is the way to go for optimistic rollups. This is pioneered by Arbitrum. Optimism also pivoted to that after spending years trying the non-interactive variant, and they insisted for a long time that's why they'll go, but they were wrong. ZK rollups started app-specific. Loopring was the very first successful ZK rollup, but it became general. It became general compute very quickly, and it surprised everyone. Everyone was really surprised by how quickly you got there, and this was due in part by some advances in the snarking machinery that made them very practical, like Plunk, for example. Plunk, which also built on previous proving system. So there was a lot of advancement in the proving systems. This is where the jump came from, basically. A ZK proving system, very, very briefly, it's a way to take arbitrary logic, compile it to polynomials, and then we stitch these polynomials together such that we can get a single, cheaply verified proof of the integrity of the whole thing. We will have more to say about this stuff in our ZK fellowship. But this is briefly what it is for now. Rollups are embedded blockchains, or in a way, like they are non-enshrined shards, if you will. And as far as the principle we have been following so far in identifying viability of chains, they are the cream of the crop. Why? Well, they outsource the most pressing concern, security, to a more secure chain, a durable secure chain. And they still get to have all the fun stuff, new token, their own ecosystem, community, all this stuff. And they also, like something else, which is very important, they also have a secure bridge from day one by design. It's part of the whole design path, is to have a secure bridge with the mother chain. So as far as our thesis go, rollups are very high in the hierarchy. Rollups are mostly in the Ethereum ecosystem. That's where they were invented. That's where the most secure chain is, that is acting as the mother chain. They are all tethered to it, and that's where most of the brain power is. Most of the rollups are EVM equivalent. The difference is nothing you need to worry about. The difference between EVM equivalent or EVM compatible is nothing you worry about, unless you are auditing infrastructure, not just smart contracts. And I'll talk about this more now. So in terms of smart contracts, you can write in Solidity and Cairo. Cairo is specific to the Starkware ecosystem. Like Starkware is a different proving system. And in terms of infrastructure, Rust is the dominant language there. When I say infrastructure here, I'm talking about things like L2 node or ZK prover circuits. That's what I mean by infrastructure, because remember, the prover in ZK rollups is something that happens off-chain, while the verifier is a Solidity piece of code that lives on-chain. So to say more a bit about ZK, you have Mina ecosystem. It's a recursive snark-based blockchain with a minimal, very minimal SDK to create simple ZK dApps. And then you have ZK dApps for voting, gaming, rate limiting. The PSE group in the Ethereum Foundation is doing a lot of innovations there. So there is some auditing demand there. But really, the bulk of it is in ZK rollups. That's where you have these massive code bases for provers off-chain, mostly in Rust, or verifier on-chain, and mostly in Solidity. In ZK rollups, it's not only Rust and Solidity that you need to know. There is a lot of theory that you also need to learn in order to become a competent auditor there. So, like as Australians say, you need to learn heaps of stuff to audit there. Some of this stuff that might seem difficult because, you know, as a society, we decided to teach things like calculus in high school as opposed to like probability theory or abstract algebra, which I think we should definitely consider like because of like the revolution in ZK and AI, which rely on these things. So the bad news is there are pockets of extremely difficult concepts that you would need to wrap your head around. The good news is, though, there is a way to make sense of the whole without understanding every single part. So once you have this holistic understanding of the entire machinery, from source code all the way to a proof, you can actually attack each part in isolation and understand it independently of how it connects to the other, but only if you have that holistic understanding. So this is actually a strategy that we're going to follow in our ZK fellowship, which will hopefully it will pave the way, hopefully, for aspiring auditors into this ecosystem without getting drowned or like getting bogged down in this corner or that corner. Once you have that holistic understanding, you know how to navigate your way through the forest. It's like you don't know every single corner of Tokyo, but if you understand how the metro works, you can, you know, move around easily and find your way back home. Okay, so we're reaching the end here. To recap, you look for durably secure ecosystems. That's where you will find developers, and if they'll, and that's where, as a result, that's where you will find demand for your auditing skills. The three main tooling that you need to have in your mind is the EVM and whatever comes with that. You are familiar with this, I think, already by now. Rust is important for two things, because we have WASM runtime, which is being used by some blockchains, especially sharded blockchains, and you have Rust in the infrastructure, like nodes and ZK provers. In terms of ZK by itself as a category, you have it's a category by itself because it's as I tell you, need to understand a whole and then attack the separate part. You can't choose to verify only Solidity verifiers. You are not going to understand it unless you have an understanding of the whole thing. And that's why I have it as a category by itself. The reason why I have ZK here instead of rollups is because optimistic rollups, you really don't need anything new. There is nothing new there that you don't already know if you are familiar with the EVM part. So for ZK, you have Solidity and Cairo for in-chain verifiers, and then you have Cairo for smart contracts as well, and you have Rust for the provers and the infrastructure, plus some theory that you need to be aware of. So this is where current or expected demand will be, in my opinion. It's these three things. This is basically the result of our investigation, basically. So these are in terms of ecosystems, these are the ecosystem that match our thesis, basically. Ethereum rollups, Polkadot Near, they are both sharded and they have a viable path towards durable security, especially if they develop ZKPs for WASM. Okay, so if you want to read more, you can find more in this article. You can almost every project I talked about here, you can find more on my Twitter feed. I have had so many debates on some of these issues that I touched on, so you can learn more there. And that's about it. Thank you.
Amazing. I am going to jump in. This is Engineer, and just read one of the questions that's in the chat. And I'm reading it out loud for anyone who's on the recording. And the question is, what about auditing CIRCOM circuits?
Oh, good question. Excellent question. So I should have, I should have included CIRCOM in the infra part. So in CIRCOM, you would write a circuit. It's similar to if you have done any hardware programming where you use the high-level language to create actual hardware circuits, it's very similar. So you would write like a piece of code, which is a circuit, and that the CIRCOM compiler, it will automatically generate a verifier, a piece of Solidity code, which will live on chain. So I would include CIRCOM as part of the infra, I would say, because CIRCOM code base, it's not something that lives on chain. It's not a, but yeah, CIRCOM is one of the ways in which you can create provers and verifiers. It would automatically generate the proofs, and will automatically generate the verifier as well. So it's definitely, it's the go-to language for ZK dApps at the moment. If you wanted to create a ZK dApp independently that has some presence on chain, CIRCOM is the way to go. And yes, CIRCOM is definitely in demand. That's for sure. In fact, in our fellowship, our very first and potentially second code bases, they are going to be in CIRCOM. So great question.
Okay, I'm jumping in to read one other question in the chat. Basically a continuation on the CIRCOM questions, and used it for a couple ZK dApps, sorry. But would like to know if you know auditing resources for CIRCOM dApp auditing.
As far as I know, there isn't any auditing resources except a few audits that have been done. I know there is a firm, a ZK auditing firm that has internal internal auditing tools that are used specifically for finding, for example, finding under constraints, things like that. But I'm not sure if they are open source. So the answer is simply not a lot, and hopefully we can contribute to that by open sourcing more material about it, open sourcing the audits that we do about CIRCOM. But the only thing that I know that I can point you to now is a few audits and potentially a few presentations about automated tools that have targeted. Yeah, I can see in the chat, it's Verities. Yeah, that's the firm that I had in mind, but I'm not sure if they open source their tools though. I don't know that for a fact. So like auditing in ZK is still very young. But according to like what I talked about earlier, if we're trying to predict where developers will go, I think it's very reasonable to assume that they're going to go there in large numbers. The benefits that ZK brings about in terms of privacy and scalability is very obvious. So yeah, hopefully we can do something about that here at yAcademy. We can improve, we can contribute to resources that are out there that can, you know, help auditors get started.
We have a question in the chat, or rather a request. Can you jump to the slide with your Twitter username?
Yes.
And I will jump in with a question of my own since I don't see any others in chat. You've given all this great alpha for where auditors should look. Would this same alpha have applied 6 to 12 months ago, or was the opportunity at a different point 6 to 12 months ago?
6 months to 1 year ago, I would say the same. But if you told me 2 years ago, I did not, myself and everyone really, we did not know that general compute in ZK is going to be a thing and this fast. We had no idea. So if this presentation was 2 years ago, I would have not talked about ZK at all. Like ZK would have been this fringe. It's interesting. We have app-specific ZK rollups. There is some work there. But now the reason why it's going to be like a massive thing is because it became possible to do general compute in ZK very, very quickly. And no one saw this coming. So 2 years ago, yeah, I think especially the end of this presentation would have been different when I talked about rollups and stuff. But in terms of the general thesis, actually, it's the same because, you know, this article that I mentioned, I actually wrote this article and this whole thesis about looking for durably secure sharded blockchains. I made this argument in 2020 or late 19 or early 2020. So my thinking has not changed there at all. Security is still the primary driver. And I think, you know, I mean, you can look at insecure by design blockchains. I don't see any signs of long-term viability there. Some of them, they even died on day one from launch. So if you have something that has been in the wild for 6 to 7 years and it hasn't worked, it's unlikely that it will ever will, unless it completely throws out whatever it's doing and, you know, embrace this security first approach and sharding, basically. So yeah.
Okay, I do not see any other questions in chat, but if you do have any questions from this talk or watching the recording, you're welcome to put them in the Discord and we will make sure that we forward them to today's speaker. So thank you very much, Ali, for giving this amazing talk on multi-chain auditing. And thank you everyone for joining.